We hear next from Vicki. Fred has stimulated a lot of recollections, and I think I'll have to curb myself from referring to them. Rattlesnakes in the desert. There were a Bolivian revolution encountered by that group, on and on. And the other thing that comes to mind is Zacharias once saying that we have accelerators like other people have mice. And in any case, Vicki needs no introduction. I only need note that he was one of the prime people Zach turned to build on what was already here, and Vicki responded with his usual good measure. I think Fred has touched on much of it. I don't need to repeat it, so I simply turn to, I think we know him as the never cool and forever passionate Vicki.
Let's install this. Let's see. No, that's right. Is that okay? You hear me? Well, I am supposed to talk about my life at LNS in the framework of the old days, so that is perfectly correct, since I belong to the old days. It's of course very difficult to speak in of 46 years, which I spent here, in 35 minutes, but I will try. We'll see how far I come. You see, I came actually to this country 55 years ago, first to Rochester, where I got an offer as an instructor and then assistant professor. And in 43, Oppenheimer asked me to come to Los Alamos. And all the time in Rochester, my wife and I wanted actually to come to the Cambridge area, where there is so much culture, music, and everything, science, so many friends. So we were very happy when at the end of Los Alamos, where we became so terribly famous for making this terrible weapon, that Zacharias came to hire people for MIT. Well, MIT is in Cambridge, so I was very glad about this and accepted right away. Together, as you know, he came there to get a few people over here, among others, Bruno Rossi, Martin Deutsch, Woodward, and some others. And we were supposed to start here the fundamental physics, which was already here, but perhaps not very active. So it was a pleasure to come here and begin again to deal with physics, with real physics, after what we had to do in Los Alamos. Now, Zacharias promised an easy life here. He said he spoke about LNS, that the Laboratory of Nuclear Science will be established and will help us in every respect. And it did. And I must say, with a certain pride and perhaps a certain shame, that in all my life I never wrote a request for money to Washington, because all this was done by LNS, by Fred Epling and others. So I just have told them what I want, and I got it. Now, I think that's, I'm not sure whether it's unique, but I think it is unique that to spend an active scientific life and never write a proposal. And I will stick to it to the end of my life. Now, I came 1946, and of course at that time at the beginning of 1946, and it was very difficult to find housing here. We had great trouble, and my family with the small children had to live on Cape Cod for half a year because the house wasn't ready. But it was great fun to be really back again in fundamental physics. For nuclear physics, of course, was also done in Los Alamos, but field theory, electrodynamics, and all this, and to work with such wonderful people. First of all, Herman Feshbach, I will talk about this later, and the young staff here, and the postdocs, Fran Friedman, who unfortunately is no longer with us, John Blatt, Amos de Chalit, and Anon Dar, and some others, and graduate students. And I must say, I really had excellent graduate students. And I mention only a few: Bruce French, Murray Gell-Mann, Kurt Gottfried, Arthur Kerman, Dave Peasley, Kirsten Wang, and so on. Now, back to physics. Of course, physics activities at that time were interrupted by sort of physics and real politics, by talks about the bomb and the desire of have an international committee to deal with nuclear affairs, to begin with the Federation of American Scientists and the Emergency Committee Against Nuclear War with Einstein and all this. So it wasn't only physics, but it was mostly physics. The beginning, of course, of all that return to physics was the Shelter Island Conference in 1947 that Oppenheimer organized and Darrow organized, where we discussed where we have to get again into the work. And that was, of course, a sensational meeting because Lamb Rutherford announced the measurement of the lamp shift at that time. And let me just tell you an anecdote to describe the fame of the physicists at that time because of the bomb that ended the war. Well, at the end of the conference, Oppenheimer had to go very quickly to Cambridge because that was the time when General Marshall, was supposed to announce the Marshall Plan. And OP wanted to be there. So he hired a plane and invited a few people, Bruno Rossi, myself, and I think Herman Feshbach, to go with him in that plane. And it was a little plane, and the weather became very nasty. And in New London, the pilot said, I don't know what to do because I should actually land. It's too dangerous. But on the other hand, the airport in New London is a military airport, and I'm not allowed to land there. And Opie said to him, well, do it anyway. So, there was already, you could also already see a surgeon there with a red face cursing us and giving a sign we are not supposed to land. And the poor pilot was unhappy. And Opie said to him, let me handle this. And so we landed. Opie got out. And here's this man cursing us. And he said, I am Dr. Oppenheimer. And then this surgeon said, are you the Oppenheimer? And he said, I am a Oppenheimer. And we are coming from a nuclear conference, you see. So he was the Oppenheimer. So right away, a red carpet was put on the floor. We were invited to a breakfast of the admiral who ran that place. And we were honored and shipped in a bus directly to Cambridge. So you see that at that time, nuclear physicists had a certain pull. Good. Now, it was the Shelter Island Conference, of course, had an enormous effect, and especially on a part of my physics activities, namely together with Bruce French, we tried to calculate the lamp shift. We even started before the experiment was done, but we didn't work very hard. That's typical for a theorist. If there is no experiment, well, of the theorists of these times, and there was no experiments, and therefore we didn't work very hard. But when the experiment was out, Bruce and I worked day and night, and actually I should actually mention that Hans Bethe produced in his usual quick intelligence at Shelter Island a semi-quantitative theory of the effect. Only the constants were not quite determined yet. And we calculated the whole thing and got the right result. And then came the dark days of my life, namely that we were really the first ones who had made that calculation, but we showed it to Schwinger and Feynman, and Schwinger and Feynman recalculated it and got a different result, but both Schwinger and Feynman got the same result. Under these conditions, of course, that you have a difficult time. Now, instead of sticking to our calculations we should have done, we recalculate, until half a year later, I got a telephone call from Feynman, you are right, and we are wrong. So, and then we were not the first. It was Lamb and Kroll who did a similar calculation. Well, you better have self-confidence. Now, so my interests at that time and the interests of the theoretical group were very much divided between fundamental electrodynamics, field theory, in other words, and nuclear physics. And of course, after our calculation of, which was a very complicated one, I got the idea actually from Kramers that what you should do, calculate the self-energy of the free electron, and since I have calculated self-energies for a long time before, and I should calculate the self-energy of the bound electron in hydrogen and then subtract, but subtracting two infinities is a difficult job, and we did it in a sort of clumsy but correct way. Then came, all this was of course cleared up and made very elegant by Schwinger, Feynman, Tomonaga, Dyson, and so on. So our calculation has only historical interest. But nuclear physics, that was in some ways a continuation of the work I did in Los Alamos, but I had several great advantages. First is, and I would like to mention it again, the wonderful support from LNS, that I don't need to worry about money and support and paying assistants and postgraduates. And the greatest advantage of all was to have met Herman Feshbach here. And then began right from the beginning an extremely fruitful collaboration of two people who I think, at least personally, are not so different, but in their approach to physics, we were just different and just complementary, wonderfully complementary. I am more intuitive, or shall we say, more sloppy hand-waving in my way of doing physics. He is more mathematical, formalistic, and that is but still appreciates also the general aspect. And so we had a wonderful team together, different approaches, but not different characters. It was a wonderful mutual understanding, not only for physics, but of all problems we meet, political. There's a deep friendship that lasted. It still becomes stronger every year in physics, in scientific politics, in real politics, and with our families. So, well, it is not time enough to mention what we did together, but the clouded crystal ball model was one of the important things, which explained measurements by Hans Marshall. We're very proud that our theories give exactly the curve, or almost exactly the curve that were measured. But let me say one of the more important things of that time was that the book, the Blatt and Weisskopf book. I decided roughly in the late 40s that such a book should be written. There was only one book available, the so-called Bible of Hans Bethe and Bacher and others, that was published before the war. So there was really a need for a theoretical nuclear physics book. And I had, again, the luck of finding a postdoc, John Blatt, who came, he made his PhD at Cornell, who came and asked him to work with me. And that was, again, a wonderful combination. Now, I would like to make sure that it is not like the famous combination of Landau and Lifshitz, where people said that there is no word written by Landau and no idea conceived by Lifshitz. But that wasn't that way. There were lots of words written by Blatt, and he contributed a lot of ideas. But he was a much more accurate man. He didn't allow any, it's a very good mathematician. He didn't allow hand-waving arguments and things of this kind. And also he made me work. I remember once I came in the morning and said to him, yesterday I saw a very interesting movie. He said, "You were at a movie? You should have written chapter 13. And so he really kept me working extremely hard. And then there was an interesting conflict with Wiley, the publisher, because I sent in the manuscript. Yeah, I always stick to the alphabetical order, Blatt and Weisskopf. And the reason is because my first paper, which had some influence on physics, was one with Wigner. And I had the luck to find a famous collaborator who is in the alphabet after me. So it was Weisskopf and Wigner. And then I made a vow that from now on, since my name was the first one in this, in that paper of the natural line width, which most of you know, I made a vow I will never change, and I will always publish in alphabetical order. So I went to Wiley and said, this is Blatt and Weisskopf. And Wiley said that we cannot do this. You are known, you are the senior author, it must be Weisskopf and Blatt. Then I fought with him. I said, I made a vow. I said, that is none of our concern. We are concerned about selling the book. And then finally I convinced him with the following argument. When it is Weisskopf and Blatt, the emphasis is on Blatt. When it is Blatt and Weisskopf, the emphasis is on Weisskopf. And he bought that. And finally it was Blatt and Weisskopf. I have made the experience in writing this book, an experience that I had later on also. It is really wonderful to write a book. Well, it's not wonderful to write a book. It's a terrible work. It always takes 10 times more time than you think. But it is wonderful in the following way, that you really have to think about everything. And therefore, you find in writing the book themes for original work. That has to be worked out, this has to be worked out. And so it was also with that a lot of original papers came from writing this book. Among others, the calculation of gamma ray radiation, which is, I think, the only place where my name enters into the language of physics with the so-called Weisskopf units. And other things, the collaboration with Walecka, who is here, and Gomez about nuclear matter, and quite a lot of things came out of writing that book. And at the end, of course, in some ways also, the clouded crystal ball work with Herman Feshbach. And the compound nucleus work with Francis Friedman, a compound nucleus and direct reactions, things that later on were really developed into a systematic theory of nuclear reactions by Herman Feshbach. Well, the field theory wasn't completely neglected. I tried to calculate with Cross and Huang the magnetic moment of nucleons. That was the pre-quark time. And nowadays it turns out that with quarks you can also not explain it so easily. But we tried to did it differently, which was it's probably not very important paper. And then the independent particle model. At that time, of course, it was the time when the shell model of the nucleus was produced by Jensen and Meyer, and everybody was astonished how come that the nucleons run almost like independent particles in the nucleus, although the interaction is so strong. And well, we tried to think about this and wrote a few papers about how this really comes about. Out of this came also the collaboration with Chalit and Walecka and Gomez. And then the back model. The back model, the famous MIT back model, was of course one of the triumphs of this place of the theoretical division. And well, I didn't contribute much. I encouraged people like Johnson, like Kent Johnson and Bob Jaffe and others to go ahead. I found it extremely interesting. I computed a few hand-waving, as usual, hand-waving arguments, but well, they put my name on the paper. I'm very glad that they did, but I'm not sure I deserve it. By the way, I would like to show this picture, which shows sort of the MIT collaboration in theoretical physics. Yes, you see here, well, this is John Blatt, that is Bruce French, that's Herman, and that's me when I was still young and black. So this sort of symbolizes the way we worked and had wonderful time together. Well, now let me say a few words about other activities, which are some more of social, educational significance. I tried to introduce a few things that were fun but didn't really develop too much. First, in the 50s, I had the graduate student dinner. We went out once a month, I think. Was it a week? No, once a month, I think, or more frequent. To have dinner together downtown with the graduate students, or with some of the graduate students in theory. And they were really very helpful. It was wonderful. We discussed, of course, mainly physics, but not only physics, also politics and general questions, personal questions. You know, it's very interesting. The relation with the graduate students has sort of changed, but that is due not only due to the changes in our society, but also due to age. The difference in age becomes bigger between graduate students and me. For example, in Rochester, I was almost the same age as the graduate students. And therefore, and at the beginning here, therefore they came to me also with problems, should I marry this girl or not? In which case I always say, if you ask, the answer is no. But of course now this is no longer that way. First of all, well, I don't want to go into social, in some aspects of our society, but this problem has changed too, not only only physics. Now, then I tried to do something which I found very useful, but then it was too hard on me, namely the colloquium question. It turned out that the graduate students did not come, or only a few came to the colloquia. And then I said, that's really bad, because it's so instructive, but I know the reason, because the speakers are usually not very good in the colloquium. And then I tried to do the following. I said, to the so-called pre-colloquium, on Thursday at 2 o'clock, I invited the graduate students to come, and I will tell them what I think the speaker is going to say. Now that's sometimes very difficult. First of all, I only know the title. Sometimes, of course, I know more about it, but sometimes I have to guess. And I told them things that may be very interesting for the graduate students, but had nothing to do with the colloquium. And sometimes it was useful. And indeed, I think it has helped that it helped me enormously, because I had to think about what the title may mean. And since I am always against specialization, I think one ought to have at least a scientific American idea of all physics, not only one specialty. In other words, I prefer to know, instead of knowing everything about nothing, I prefer to know nothing about everything. And this was always my fun in life. And then I had also a seminar, how to give a lecture. And there were not more than 12 people, and they had to give a lecture. They had to choose a subject, and preferably not their own thesis subject, but another subject. And then they had to give a talk for 1 hour, and the second hour of the seminar, we criticized him. You didn't explain this, you didn't explain that. You assumed that everybody knows the foundations, which is always a mistake, not only of young speakers, but also of older physicists. And so that was fun, but it also somehow lasted a few years and didn't, not longer. Well, then of course one important event in my life was, I have still a few minutes, was 1960, when the director of CERN, Bacher, died in an airplane accident. And the moment I heard this, I thought that means something in my life, because I was always following very closely what happens in European physics, and I tried also to help with advice and spend my sabbaticals over there, since somehow I find physics must be international, and that's one reason. And European physics, after all, has really created physics. And somehow the ravages of war were terrible, and we have to help them. And I also felt a feeling of, how shall I say, of I owe Europe so much. The whole culture, my education, in spite of the terrible things that happened there, it is in Europe where many of my cultural roots lie, and I felt I would like to pay back some of this debt. And when I then was asked to become Director General, I accepted, mainly because of that reason, but also because I never had an administrative job, except that I was mayor of Los Alamos, which is sort of a ridiculous job. But I was elected mayor of Los Alamos for 2 years, which is great fun, but that doesn't come here. You can read it in my autobiography. And then another reason, which I never admitted, of course, was that I love skiing. And of course, Geneva is a wonderful center for skiing over the weekends. So, but I never admitted that reason. And God punished me for this, because I had a rather bad automobile accident just when I started becoming director, so that the skiing, I had 2 years no skiing. But anyway, it was for me a tremendous experience, not only from the political point of view, it's the first international institution that is not only paper shuffling like the many UN organizations, but where real work is done on an international basis, where the European nations work together, and also a lot of Americans. And that was really, for me, an enormous experience, almost, or perhaps even more important than the Los Alamos experience of creating an international spirit. And it was the first year where the machines were working, where research has to be organized. It was just a great thing. And I must say, I enjoyed every minute of my directorship, although there were many difficult problems. But actually, the collaboration was no problem. Once a journalist came to me and asked me, is it not very hard to have Britishes and French and Germans and Italians working together? I said, that is not hard at all. What is hard is to have two Italians work together. And that was just after I had a discussion with Sikiki and Rubia. Well, when I came back, I didn't want to spend my life at CERN. Maybe I should have stayed a little longer because the tradition of 5 years has been kept, and I think it's a little too short for a director general. But I came back after all, with children and friends and so on, and I don't want to live all the time over there. I came back as a different person in a way because I have this administrative experience. So they asked me after a year to become the head of department, the physics department, which I accepted. But you see, I was a little different from the other heads because I have learned at CERN there were so many very good people with experience who took over the job of the financing and the, in other words, I could delegate authority and really think about the important things. And I tried to do this also in the department where it is much more difficult because a department is much more varied than a laboratory like CERN. But I ascribe it in some ways to my laziness. I don't want to go into details of the finances. I leave this to others. And I had good helpers. That Pete Gould, so many of you remember, Al Hill, and then Tony French, who were my right hands. And so I really could do it. And at that time, things were not so bad as they are now. I mean, it was much easier to get money. Indeed, at that time, basic science was very well supported by Washington. And that's why it was possible to hire very good people, especially in theory. We had Veneziano, who is here, fortunately, as our guest, and then Sergio Fubini and Steve Weinberg. And so we had really a wonderful addition, and it was a pleasure, in a way, to be head of department, although it does cut, as all my colleagues who were head of department can admit, it cuts into your physics time. Maybe not with Herman Feshbach, because Herman Feshbach works 48 hours a day, and then he has time for physics. Well, I'm now coming to the time where I was getting old. I retired, under quotation mark, in 74, and since then my activities sort of decreased, but still it is I was able to write books, my autobiography and other books, and a book with Kurt Gottfried on the concepts of particle physics, which was not the most stolen book of the library, as Blatt and Weisskopf was. And I'm not sure whether it still is, but I don't think so. But then, when you get old, it is a little harder to do physics and to understand physics, what's going on. And what I would call myself now to be a passive physicist. I like to hear, and there are wonderful friends who always have the patience to come to my office to explain in detail, and who don't mind my stupid questions. Maybe sometimes they enjoy it even. Quite a number of people, like Bob Jaffe, Ken Johnson, and Alan Guth, and many others, and who tell me what's going on, and the experimenters, Henry Kendall and Francis Friedman, and tell me what's going on. And I enjoy this. And then also in other fields, in solid state, like Kastner and Bergenau, when he still was with us. And so it was a pleasure to to listen to physics, and it's still my pleasure to listen to physics, but because physics is still terribly exciting. And, but of course, when you're getting old, you also want to do some things which you always postpone, interested in other things, do more music, do more reading, do more traveling. And but still, I find to be a member of this community. And every time I come, and I come less frequent than before, I feel these are friends, and here is my home. And of course, I made two physical observations, experimental observations. One is that time runs now faster than before. Now, whether that's physics or not, I don't know. And also, gravity becomes stronger because it's much harder for me to go up the stairs than before. Well, thank you very much.